Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Finding the Percent of Change, and then there's subtitles underneath that, Finding the Percent of Increase or Decrease, and Markups or Markdowns. Okay, follow along with me here as I talk about the essential vocabulary of this lesson. Percent of change is the percent that describes how much something has increased or decreased in relation to the original amount. That's actually a big part of this. We'll talk more about that coming up. Sometimes an amount of an item will increase or decrease from its original amount to a newer amount. We can then find the percent of increase or the percent of decrease in those situations. And you can see I've kind of given little flow charts here. If we have an original amount goes to a newer amount, it's either going to increase by some type of percent or it's going to decrease by some type of percent. So that's what these problems are all about. All right, here's how the math is going to work. How to find the percent of change. Now, I hope you realize we don't always just say percent of change. We sometimes say the percent of increase, or we say the percent of decrease. Step one, we're going to find the amount of change. And how do we do that? We're going to find the difference, which means subtract, between the newer value and the older value. When I say value, I'm talking numbers here. So we're going to have an original, we're going to have a newer one. Just like I mentioned above with the little flow chart thing here, original and a newer amount. And we're going to subtract them to find the amount of change. Pretty simple. Now, if you get a negative answer, we're going to drop the negative because we're actually wanting the absolute value of the amount of change. You might remember from 6th grade math, absolute value is the distance from zero, which takes off any negatives that you might get. So that's going to happen here to get the amount of change. Then step two, we're going to divide. And you're used to doing part divided by whole. Well, this time, the part is the amount of change. And the whole amount, well, there's two different whole amounts. There's the original one, and then there's the newer one. It's the original amount that has to be your whole, has to be your total, has to be the denominator. So we're going to divide in that order, those two things. And then we're going to convert the decimal to a percent, like you're used to doing, to 5% by moving the decimal point 2 places to the right. You could even multiply by 100, but most people just move the decimal point 2 places to the right. Again, I cannot emphasize enough to make sure that your denominator is the original amount, not the newer amount. That's so important. And it goes back to what I highlighted in this box. The percent of change is always in relation to the original amount. It starts at the original, then it goes up or down by a percent to get to the newer. That's why the original amount must be what you're dividing by to calculate your percent. Okay, let's look at an example that's already typed up for us. Problem number one. Last year, the price of a shirt was $17. This year, it's now $20, so obviously it went up. Find the percent of increase for the price of the shirt. Round the percent to the nearest tenth. All right, so step one, as I told you, we're going to find the amount of change, and the way you do that is you subtract. Not a hard thing to do. If you get a negative, you're going to drop the negative because we want the absolute value. That will be your part. Now, the denominator must be the original price, and the words original price were never in these sentences, so you have to do a little interpreting. Think about this. We had last year's price, we had this year's price. Last year's price, that's the original price, whereas this year's the newer price. So yeah, you have to do a little interpreting, but that doesn't always going to be hard for you. Like this one's pretty clear to see. So last year's price, that's the original price, that's what you must divide by. Using your calculator, you'll get the decimal, and you guys remember move the decimal point 2 places to the right to get the percent. This said round the percent to the nearest tenth, and we've talked about this before, but I have it at the bottom of your page. Do not round early. The decimal you get from the division problem, quotient means division, that's the decimal form. You need to move it 2 places to the right to get it in the percent form. Then you round to the nearest tenth. So if I would have rounded to the nearest tenth too early, I would have had 0.2, and I would have thought this is 20%. That's not what the directions are saying to do. It says round the percent. Not round beforehand. It's round the percent to the nearest tenth. Okay, let's do two problems together. Are your pencils ready? Are your calculators ready? It says the object went from 64 feet up in the air to 55 feet. Find the percent of decrease. So obviously it used to be high, now it's a little bit lower. So that's why it's decrease now, not increase. So step one, we're going to subtract. And it honestly doesn't really matter what order you subtract in. Now, I know that sounds horrible for me to say as a math teacher, because normally it does matter which way you subtract. Because if you subtract the one way, you'll get a positive. You subtract the other way, you're going to get a negative. But the reason I can say I don't really care which order you subtract in is because what we talked about here, we're going to get the absolute value, which means the negative is going to drop anyway, even if you get a negative. So that's kind of nice about these math problems here. If you accidentally subtract in the opposite order from what I do, it won't matter. The absolute value will be your numerator, the amount of change. If you're wondering why I subtracted in this order, I tend to do the newer amount minus the older amount. But again, doesn't really matter if you do it the other way. What does matter is that your denominator must be the original amount. Now, number one, it was the original price. Number two, we're not talking price here. We're talking about how high up in the air this object was. So, can you figure out which one was the original? Hopefully you can realize where it started from, where it went from. That's where it started. That's the original amount. Where it ended up, it went down to 55 feet. That's the newer elevation up in the air, okay? Where it started from, that's the original. So that's what we're dividing by. Please do not think it's always going to be the bigger number or always going to be the smaller number. That's not the case. However, I will say this. If you're finding a percent of increase, like on number one, then the original should be the smaller. But if you're finding the percent of decrease, then the original should be the larger amount. But if it just says find the percent of change, then obviously these little tricks are not going to help. You're just going to have to interpret the problem. All right, I've been talking a lot here, trying to explain, making sure it makes sense. Let's now use our calculator. 9 divided by 64 is going to give you this glorious decimal, 0.140625. Now, the directions did not say to round to the nearest tenth on this problem of a percent, so we're going to keep this the way it is. Move the decimal point 2 places to the right to get it in percent form. That's going to make it 14 point. Now, if we were rounding to the nearest tenth, we would know it's a zero's next, but the one after that is a 6, which is 5 or more. So this would go to 0.1 if we were rounding to the nearest tenth, but we're not. So 14.0625%. Let's do one more together. Problem number 3. Today, the temperature is 91 degrees Fahrenheit, but yesterday it was 78 degrees Fahrenheit. It's kind of funny. If you're reading this problem and it's like the dead of winter, then these temperatures are ridiculous, but whatever. Pretend it's the summer. Find the percent of increase in temperature from yesterday. Now, if you're like, Underkoffler, I thought it decreased. No. Pay attention here to the details. Today, it's 91, but yesterday, it was 78 degrees. Yesterday is the original temperature. It's the older one. That's the more original one. So keep that in mind for when we set up our fraction. All right, let's subtract. I tend to do the newer amount, which is today's temperature, minus the minus the original amount, the older amount, which is yesterday's temperature. So that's going to give you 91 minus 78, which is 13 degrees. That's your amount of change. That's your part. That's your numerator. By the way, you notice I put units of measure here, feet and degrees. It doesn't really matter that I did because these are not final answers. So unit of measure, kind of optional there. Who is the original temperature? Well, I already explained this. The temperature yesterday is older than the temperature today, and the older amount is the original amount. So that is what you must divide by. All right. 13 divided by 78, use your calculator. It should give you 0 point something, as we talked about on many percent problems, unless the part is somehow bigger than what you're dividing by, which is not the case here. That's going to give you 0.1, and then the 6 repeats. I know a lot of calculators put a 7 at the end. We've mentioned this earlier this year. That's your calculator rounding at the end, so ignore the 7 at the end. These directions do not even tell us to round. So I know you're like, should I put the repeating bar here? I would not yet, because this is not percent form yet. So I like to put at least 4 digits, and then if it goes on forever, ... This is 16 point, and now the decimal part of the percent, since it's a repeating 6, that is where you put the repeating bar. You cannot put the repeating bar on any digit to the left of the decimal point in percent form. You can't have a repeating whole number section. That's impossible. You can only have a repeating decimal section. So keep that in mind. This is why you don't want to put the repeating bar up here on this first 6, because then you would have had a whole number repeating in percent form, which is impossible. All right. Problem 4 and 5 are on the next page. I would like for you to read them on your own and try them on your own. So hit pause on the video, do 4 and 5 on your own, and then hit play when you're ready to see how you did. Okay, have you already done numbers 4 and 5? If you did not, you need to hit pause now and do those problems. All right, first step to finding percent of increase or decrease is to subtract. Like I said earlier, since we're going to take the absolute value, which is going to knock off any negatives we get, it really doesn't matter if you accidentally subtracted in the opposite order of me. You don't have to erase it. It's fine. The amount of change is 2.5 ounces. Now, what do we divide by? We have to divide by the original amount. Do you see that it said that the box used to contain 24 ounces, but now in the present tense, it's 21.5 ounces. So that's the newer amount, what it is today. What it used to be is the older original amount. So you must divide by that original amount. By the way, when it says find the percent of decrease, then the higher number should be the original amount, because then it goes down to a lower number, which is the newer number. So that's another clue here. 2.5 divided by 24. Calculator gave you 0.10416 repeating. I know I told you guys earlier, don't put the repeating bar too early. But since this is definitely not going to be the whole number part of the percent, putting it early was fine. 10.416 repeating percent. And yes, you can have repeating decimal in a percent. We already had it back on problem number 3. Problem number 5. Now, they give us a lot of numbers here on number 5, but notice these are years. 2020, 2025, these are years. Do they want the percent of change of the years? No. It says find the percent of increase in population. So it's the population numbers that we should be using for our math, not the years. So we subtract, and we can see that it changed. It went up by 132 students in just 5 years. That's pretty significant. So 132 students, that's the amount of change. We need to divide by the original population, which was the older one from back in 2020. So that's the 678 students. Divide, you're going to get 0.01946. And this was a really ugly decimal. You probably couldn't even tell where it repeated, which is why the directions said round to the nearest tenth of a percent. So don't round too early. Do not make this 0.2. If you did, you rounded the decimal form to the tenths. We need to round the percent to the tenths. So move the decimal point 2 places to the right, and then ask, should it be 0.4 or should it be 0.5? Well, look at the digit to the right. To the right is 5 or more. So this 4, which would have been 0.4%, is now 0.5. So 19.5% when you round to the nearest tenth of a percent. Okay, hopefully you fixed whatever you had to fix. Let's talk a little bit more about some other types of percent of change, markups and markdowns. Follow along with me. When it comes to selling items, there are markups and there are markdowns. We're going to talk more about this on future guided notes, but let's go ahead and introduce it to you here. A markup, this is worth highlighting or underlining. A markup refers to the amount of increase from the wholesale cost. Now you're like, what in the world is wholesale cost? Well, I tell you here in parentheses. It's how much the store had to pay to get the item. So it's a markup is the increase from the wholesale cost for an item to the selling price of that item. So think about this. Stores have to pay money to get items, but then they have to mark it up so they can earn a profit. So it's going to mark up to what the selling price is for you, the customer. The wholesale cost is the original cost because that's the first cost that happened in the timeline. Then it's marked up to the selling price, which is the later price. So I highlighted this for you probably already on gray in your paper. It's on yellow on my screen. This is huge. The wholesale cost is the original cost. Now, a markdown refers to the amount that an item's cost is decreased from its original price. Now, spoiler alert, number 6 and 7 are not going to even mention markdown, but we'll talk about markdowns on a future packet of guided notes. I thought I should mention it here since we're now going to talk about markups. So markdown is the opposite. It's a decrease. All right, here we go. Problem number 6. I'll do this one with you, and then you'll try 7 on your own. A clothing store is selling new t-shirts. The wholesale cost of a t-shirt is $4.50. That means the clothing store had to pay that much to even get the shirt or the shirts. If the store sells the t-shirts for $13, and I should have said $13 each because that's what we're talking about here, what is the percent of markup? So just like we did with percent of increase problems or percent of decrease problems, we have to first find the amount of change. So how many dollars did it go up by? So we're going to simply subtract, and we're going to see that it went up by $8.50. And remember, that amount of change, that difference, is always the numerator for your percent of increase or decrease problems. Now, we have to divide by the original cost. And as I mentioned up here, highlighted, the wholesale cost is the original cost. And if you read the word problem, it told you the wholesale cost was $4.50. So that is your denominator. And this is unique. The numerator is bigger than the denominator. I'm going to tell you guys this right now. With markups, sometimes the percent of markup is actually more than 100%. I know that doesn't sound fair to us as customers, but stores do have to make profits. They have to pay their employees. They have to pay the truck drivers that ship the stuff to them. So lots of things are involved here as to why markups could be over 100%. So divide. Yes, it's going to be not 0 point something. It will be 1 point something. This happens when the numerator is more than the denominator. So use your calculator. You should get 1.8 repeating. Don't put the repeating bar too early because this 0.88 is going to end up being the whole number part of the percent along with the 1 because we're moving that decimal point 2 places to the right. 188.8 repeating percent. By the way, you shouldn't be surprised that it's over 100% increase when the new price is more than double of the original. All right, moving on. Problem number 7. You're going to try this on your own. So read the problem on your own, hit pause, do the work, get your answers, and then hit play once you're ready to see how you did. Okay, have you already done number 7? If not, hit pause now, do your work. Here we go. Hopefully you subtracted. And I don't really care which order you subtracted in. If you got a negative, you're going to drop it anyway. That is your amount of change. That's your numerator. Divided by the wholesale price. Because remember, I told you this earlier above in the paragraph. The wholesale price is the original price. So that is your denominator. And so once again, you're going to get something bigger than 100%. In fact, this one's bigger than 200%, which probably shouldn't surprise you. Look how much more they're selling the necklace for than what the wholesale price was for the jewelry store to acquire it. This is going to be 271.875% for the markup. All right. Moving on. The last 2 problems of these guided notes are not on markups. They're just percent of increase or decrease problems. However, I made it a little bit different. First of all, there are tables, and you're going to have to pay attention to what the problem is asking you to find. Like, let me get you started here on number 8. Lorenzo's bank account balance during the first 4 months of the year is shown in the table below. Find, okay, pay attention to this. Find the percent of change from February to March. So We only care about those two values on this problem because that's what they're asking us to find the percent of change from. Pay attention always to what the problem wants you to find. The other reason why number 8 and 9 are a little bit different is because there's an extra part to the directions. State whether it's a percent of increase or decrease. You'll see at the bottom, I started a sentence with, and then it ends with a blank. You're going to fill in that blank with the word increase or decrease after you've done your work. Although you could honestly, you could just look back at what happened and you could already put increase or decrease. Okay, I've told you enough. Try 8 and 9 on your own. Hit pause, do these two problems, and then hit play once you're ready to see how you did. Okay, problem number 8. If you didn't do it yet, you better hit pause because here I go. From February to March, we're only going to use those two numbers to find the amount of change. I don't care if you subtract it in the other order, it doesn't matter. We're going to drop this negative anyway. We must divide by the original amount. Now, that doesn't mean divide by January. This problem is not asking you to find a percent of change from January. No. It's asking you to find a percent of change from February. So, from February to March, February is the original amount because it comes earlier in the timeline. So, that must be the number you're dividing from. That's where the percent of decrease comes from. By the way, spoiler alert, it went down. That's a decrease. All right, divide. You're going to get this lovely decimal. The directions did say round to the nearest tenth of a percent. Don't round too early. Don't make it 0.1. Move the two places to the right. 6.8 or 6.9. Well, the 3 is less than 5, so it's 6.8%. Decrease. Feel free to hit pause if you have to fix it. And finally, number 9. We got subscribers of a social media account. By the way, if you didn't know what the capital M was, that's million. I bet a lot of you already knew that because you probably follow social media people on YouTube or Instagram or whatever. Where do we want to find the percent of change from this time? This time it says from 2021 to 2022. So we are looking here. So I don't even need the first two numbers that they gave me. I just need these. We're going to subtract. And you can keep it in decimal form. It's fine. It won't matter. That's going to be 0.26. That's your amount of change. We have to divide where it came from. The original amount, not 2019's original. We're not talking about that. We're going from 2021 to 2022. So 1.81 is the original amount in that situation. Divide, you will get 0.1436, yada, yada, yada. Directions that round to the nearest tenth of a percent. So move that two places to the right. 14 point, well, will it be 3 or 4? The 6 is 5 or more, so it's going to round up 14.4%. And as you can see from 2021 to 2022, the number of subscribers increased. In fact, they continue to increase this entire 4-year time frame. So that's the word you put in the blank. And that concludes the guided notes on finding the percent of change. Thank you for watching. We'll see you next time.